Sup, fam? Yeah, bet you didn't think I was hip. Think again. Today we're gonna do textures, because I think it's pretty neat. I think a triangle is pretty neat. Our triangle, our quad, but it can be neater, I think. So we're gonna put some textures on this some bitch. Let's put that away. So, so how do we do that? First of all, we gotta find an image. So I'm just gonna let's go Google. I'll just Google nice texture. Let's see what we can find here. Find something neat. I'm very picky with my textures. This one looks pretty good. Yeah, this is pretty cool. I'm gonna save that. And let's go to graphics course and put it in here. Don't ignore that. That's nothing. Yes. I forgot. Oh no. Okay, there we go. So here I have our little texture in our I just put it in the root of the project there. Great. So there is a lot of different ways to load a texture or load a image file, I should say. It's kind of a pain in the ass, to be honest. What I usually do is I just write a Targa importer, because it's such an easy format to import it. You can just write your own very easily. But I thought we would use something that can load, JPEGs and PNG and so on. So I found this pretty neat little thing. It's called stb_image. So here it is. So this guy called Nothings, it's an interesting name, has a bunch of just like header only one file stuff that's very nice. And one of the things he has is this stb where is it? There it is, image.header.h. So I'm just gonna go ahead and download this. I don't know if there's an easy way to do that, actually. Let's just I'm just gonna download this whole thing. So let's download everything. And not there, please. Go. Yes, I already downloaded it before, because the library I was gonna use it doesn't exist anymore. So I was like, fuck, I have to find another library. God damn it, but here we are. So I'm just gonna take I'm just gonna open it up, and then I'll take this stb image and just drag it into our include folder here. Just like that. Plain and simple. So now we should be able to include this in our project. So let's see. stb image. Let's compile. All right, that works. So the file you're supposed to use, or sorry, the file. Let's put it down here under textures. Very cool. The function you're supposed to call is sbi load. There we go. Hello? Oh, there we go. Yes, stbi, sorry. stbi underscore load. That's why I didn't get autocomplete. So it takes a file name, and that's from the current directory is the relative path. So since I put it in the project folder, and that's where the working directory is in Visual Studio when you debug, I'll just type texture.jpg. All right, and there's a few things. It's an int pointer to an x, an int pointer to a y, an int pointer to channels in file. Okay, and then there's this int desired channels thing. So x and y is the width and height. So I'm just gonna do those, width, height. So I'll provide those in as pointers, like so. And then you get this in pointer channels in file. And that's gonna be how many color channels are in this image. So, you know, the most common one is gonna be RGB. So that's just 3 color channels, red, green, and blue. But if you're doing, you know, sprites perhaps, then you might want to have an alpha as well. So then you might have 4, or maybe it's grayscaling on a 1 and so on. So it's just a neat little way to get that. And then we can do desired channels, so we can force this library to make the image some amount of channels. So if it is an RGB image, but we're saying like, okay, we wanna load this into OpenGL as a 4-channel image, we can force it into a 4-channel. You can force the data to be 4 channels anyways. But if you don't care, use type 0, so it will just take whatever the file is. All right, and it returns this stbi_uc, and that's unsigned char, so that's just a type def for unsigned char. So what if we just do stbi_uc like that? Text data, I'll call that, and that's gonna be the actual data of the texture. So in the case of most images, it's just gonna be 1 byte, 1 byte per color. So if we actually looked at that data, it would be, you know, red, green, blue, red, green, blue, red, green, blue, and so on. If it was a red RGB image. Got some comments about me drinking tea. I love tea. Yeah, we're just gonna take this little pause, just like marveling what we just wrote. So beautiful. All right, anyways, how do we create a texture then in OpenGL? And it's very similar to how we create buffers or really anything. We do GL gen textures. Like normal, it expects how many textures we want to generate. So if we want to generate an array of textures, we can do that. We just want to do 1. And just as every other object in OpenGL, we are supposed to store the texture as a handle, so it expects a pointer to those handles. So I'll just do texture and provide that exactly the same way I did with the you know, EBO and the VBO here. So now we have our texture, and the way we bind a texture is with the GL bind texture function. So we'll do GL texture, 2D and texture. So very similar to the vertex buffer system, there are multiple slots for textures. So there are not just one type of texture, you know, there's 2D textures, and then there's cube maps, and so on. So we have to specify which type of texture we want to bind to, and that will go in, you know, the appropriate slot. So we are saying we want to bind a 2D texture, and yeah, then we provide the handle to that texture. To the texture we want to bind, I'd say. Okay, so now we have the texture bound. How do we put data in it? And that's with GL text image 2D. All right. First, it has a target, and just like with the buffer data, it's expecting which slot we want to put data in, and we want to put data in GL texture 2D. That's the slot of texture we want to put data in. Then it's level, and that's the. Let's actually check the documentation just to make sure that we're getting this right. Let's see here. Specifies the level of detail number. Level 0 is the base image level. Level N is an nth mipmap reduction image. All right. So this has to do with mip mapping, which means that if the triangle it's rendering is very small, or it's using subpixels to figure out how much of the texture are you actually using, like are you skipping over a lot of pixels because the triangle is small, then you can tell it to use a mip map. map texture instead of using the original texture as is. And this is which load level we want to load. But we just want to do 0. We don't care about MIPS right now. And however, we have internal format, and that's how the data is supposed to be stored in OpenGL. So we'll do GL RGB, just standard. Then we got the width, and we just specify the width that we got from STBI load. Then it's height, and we just do height. And here's border, and what does border mean? This value must be 0. Okie dokie, I got it. I have no idea. Okay, and then it's format. And that this describes which format is the provided texture in. And here's where the channels come into play. So if it's a 3-channel image, then we want to specify GL RGB. But if it's a 4-channel image, we want to specify GL RGBA. Or, if it's a 1-channel image, we'll do GL red, for there's only 1 channel in the source data. In our case, I guess I'm gonna assume it's RGB for now. We could do something fancy like checking the channels. You might want to do that depending on which type of texture you chose, but I'll just do GL RGB here for now. Do it as simple as I can. And then we have type, and that's which type the data is. And in our case, it's unsigned char, so I'll do GL unsigned. Well, it's a byte here, but unsigned byte, unsigned char, same thing. And then we have pixels, and that's just the raw data, and we'll just pass it text data there. Cool. Okay, so I compiled and I got unresolved external symbol STBI load. And the way this guy shows to, if I actually go check the header, and go to the top, the way that this guy has chosen to do his little library is that instead of doing it, as a pure header-only library, where every single function is defined when you import it or when you include it. The way he decided to do it is that one C++ file in your project has to define this STB image implementation before it includes STB image. And what this does is actually define all of the functions. So the header works like, a regular header in, for example, in our shader file, where we only declare functions, we don't define them. He has set up his library to work like that. However, we have to ourselves in one C++ file define this STB image implementation, and that will actually add all the implementations as well, so that they're implemented in one C++ file. In our case, we only have main, so we'll just do it in main. So we'll just do define STB image. Is that how it was? There we go. So kind of weird. I've never actually used a library that works like this. This is the first time I've seen this, but I don't know. It's not too complicated. I'll take that weirdness for just having one header that I just need to copy in and include, and then it just works. Huzzah! Okay, great. Nothing changed, but we did. Excuse me. But we did create the texture. At least I think we did. Maybe we should just break here. So I'll just put a breakpoint here to see what actually happened here. So after the STBI load, let's check the width. So that's 2.5K. Okay, so that's what it was, I think. Height is 1,600, so that's cool. Let's how many channels? Okay, 3, so that's good. So my GL RGB will work, because only 3 color channels. And then data is stuff. Okay, so that's just stuff. And that's what I want. I don't want this to be null pointer. Great, and the texture, let's see what that becomes. 1, okay, so that's a valid handle, so the handle, it gets, gets made. So how do we draw this? Okay, first of all, we have to do a little bit more setup on the texture to actually make it valid. I think this is the better way to approach this, is to do the setup first. We have to set 4 parameters on a texture for it to be a valid render texture, and those are yeah, we gotta do GL texture parameter I. That's the one I want. Text parameter. Excuse me. So we're gonna call this GL text parameter I, and what this function does is setting a particular parameter on a texture. So each parameter doesn't have its own function that you call. Instead, you have this one function that you give an enum into to say, like, this is the parameter I want to set, and I want to set it to this integer value. So that's how mostly OpenGL sets up its parameter stuff. So that's cool. So let's see, targets. Yeah, we know about that. Here we go. So p name. Specify the symbolic name of a single value texture parameter, and there's a bunch of them, but the ones that are required are these ones: GL texture wrap S, GL texture wrap T, GL texture min filter, and GL texture mag filter. All right. So let's take one at a time. So we'll do GL text parameter I, and then okay, so here's the targets. We'll do GL texture 2D, and then it's the p name, so that's an enum. So we'll do GL. This is which parameter we want to set, and we want to set texture wrap S, and then we'll set the parameter to some value. But first, I want to explain what is texture wrap S, and probably if I just Google it, I'll get some helpful maps. Okay, here we go. Okay, there we go. Just open this new tab, please. There we go. Okay, so the wrap defines what happens when you get to the edge. Okay, so we haven't really talked about sampling textures yet, but hopefully it sort of makes sense that what happens if the texture is sort of smaller than the quad we're rendering it to. What should happen then? GL repeat. So if we set the wrap parameter to repeat, that means it will continuously sample from the beginning. So it will wrap back to the beginning as you go past the edge. So we'll get this tiling texture, like this cat's here. So the cat is the texture. And this tiling is what happens if you put GL repeat as the wrap option as you sample past the texture border. Here we have GL mirrored repeat, so it's sort of the same, but it will flip the texture up and down as you go past the edge. Then we have GL clamp to edge, and that means if you go past the border, it will just sort of clamp to what the nearest border color is. So it will keep the nearest border color. And GL clamp to border will be it returns black as you sample past its border. All right. So that's what the wrap is, and you know you can pick whichever you want. I'm gonna pick. I don't know. Let's do GL repeat. Yeah, that's cool. So we'll do GL repeat. All right. So what does the S mean, and what does T mean? And I don't know why it's called S and T, but those are the X and the Y axis. All right. So this is what you can specify a separate wrapping option for the x-axis going off the left and the right side, and the y-axis going up and down. So you can specify those as separate wrapping options if you want. We might actually want to do that. Let's do clamp to edge here, just to see what that looks like. Okay, so that's wrap, and then we have the mag and min filter. Oops. GL texture mag filter. So what's that? And I think actually here we go. Mag and min filter decides what to do when there. I'll start with mag. So mag is when there is not enough pixels to sample what you're trying to sample. The biggest, or you can see it as the image is too big on screen. Like the image is bigger on screen than the actual textures, so there's not enough pixels on the textures to fill all the pixels on screen. And it's and the parameter decides what do I do in that case where I'm sort of in between two pixels. And I think there's more than two, but the two pictured here is GL nearest. Well, it will sort of grab just whatever the nearest pixel happens to be and just make that the pixel, which will give you this, pixely look, very sharp edges. And then you have linear, where if you're in between two pixels, it will blend between the two nearest pixels. Yeah. So you'll get this blurry effect, which, looks a little bit better, I would say. It depends on what you're doing. If you want to do pixel art, you probably want to do GL nearest. If you want to do realistic art, you probably want to do linear. We'll do linear. And the same goes for the min filter, but that's reverse. If you're going too small, I don't actually know exactly what it does, because you should have enough pixels to go around. But I'm guessing it still applies a filter so you don't get random pixels. Where if you would have, okay, I have one pixel here that's supposed to be 3 pixels because it's been shrunk down. I'm guessing it will blend between those 3 pixels to create sort of an average color instead of picking, one at random, or picking the one that's closest, really. And, GL nearest will do the opposite of just picking the one that's nearest. So you'll get sort of patchy pixels if it's way too small, and you won't really be able to tell what it is anymore because so much information is lost. I'll pick GL linear there as well. So now we've set up the texture enough. Excuse me. We've set up the texture. That OpenGL is ready to render it. Oh. So that's pretty cool. See, what's so annoying is that, in real life, I always take, when I was having classes in real life, I was having this, coffee pauses where I would, think and, stroke my beard and stuff, because I know everyone else was typing in the class. But I know you guys are just gonna hit space for pause and then type what I'm typing and then unpause. So all of these pauses are just me, just fucking, sipping tea, and you guys are waiting for me to type the next thing. So maybe you shouldn't pause. You know what? Here's a fucking... maybe it's your fault. Don't pause. You expect me to drink tea. I'm putting the burden on you guys. Alright. Enough tea pondering. It's time to code. So how do we sample a texture, alright? So sampling a texture is fetching a color at a specific point in the texture. And how does that work? Don't worry about that. It's nothing to worry about. Just don't worry about it. Okay, so I'll just do this. And the way we sample a texture in 3D graphics is through something called through something called UV coordinates or texture coordinates. I'll do UV coordinate or text coord. And it's called UV just because that's what we call the X and the Y axis in this context. We call the X axis U. That's not a U. And we call the Y axis V. And why do we do that? I don't know. And the top left corner is specified as 0, 0. I believe. I actually don't remember, but I'm like 95%. It doesn't matter, okay? You can put 0, 0 wherever we want. And the bottom right corner is going to become 1, 1. 1, 1. and that's the UV square. Whoops. So what's gonna happen if I draw a little smiley face? God, that's creepy fucking smiley. Looks like little fucking pupils. And he's angry. I'm angry. Alright, so what's gonna happen is that we're gonna tell OpenGL to sample this texture and sample it at UV 0.5, 0.5, for example. And that will give us the pixel color of the pixel in the middle, in the absolute middle of the square. With applied filtering, you know, mag and min filter. And if we say, oh, I want to sample 0, 0 from this texture, it will give us the top left pixel of the texture. And, you know, 1, 1 will give us bottom right, and so on. And this is what the wrapping does. If we give it a UV value that's past 1 or past 0 in the negative direction. So, you know, if I say, okay, I want to sample it's 1.5, 0.5, which is clearly past the 1 mark in the x direction, or in the u axis, I should say. Then it will apply the wrapping option for what it will actually return. You know, if we have clamped the border, we're gonna get blank or black. If we do clamp the edge, it's gonna clamp it to, you know, the closest UV edge here, or repeat, or so on. But for our intents and purposes, right now we're just gonna worry about, you know, 0 to 1 UV square. So that's UV coordinates. So let's add UV coordinates to our quad, all right? Because right now we have position and color, but we want to add UV as well, because we want to add, you know, obviously this corner of this UV square is very cleanly maps onto our excuse me, our quad that we have. Sorry. So let's see, bottom left. I actually forget. I gotta check. Am I fucking bullshitting you? I thought UVs. Let's check what this guy says. It's been so long since I did UV, actually, honestly, and I always forget that as well. I'm just like, I think it's top, and then it's like, no, I was wrong. I gotta flip it. Doesn't fucking say. It does say it's top left. Let's just do top left. I gotta be confident. Okay, here we go. So then that means bottom left is gonna be 0, 1 in UV texture. So I'm just gonna plop that at the end of each vertex. Remember, we have interleaved attributes in our vertices, which means that, you know, this is gonna be the first vertex. I'm just gonna add UV coordinates to that attribute list for every vertex. So we're gonna have bottom left UV coordinates, then we're gonna have bottom right, so that's gonna be 1, 1. Then we have top right, so that's gonna be 1, 0. Whoops. And then we have top left, which is 0, 0. There we go. We've successfully added texture coordinates to our attributes, to our buffer data, I should say. And now we gotta add attributes. So here we have all the attributes. The attribute bindings, and before we said, okay, each vertex is 5 floats big, but that has clearly changed now, because now it's not 5 floats anymore, it's 7 floats. So we gotta update the stride for position and color. Even though we haven't changed those, we gotta make sure that the stride is always taking it to the next position or the next color. And you know, if we jump 5 floats from the start of the position, we're gonna end up here, and it's gonna read this as the position, which is clearly wrong. So we gotta update the stride for our attributes. If this doesn't make sense, please rewatch the attributes. I think it was the previous one, the attributes part 2 video. Offset is still the same though. We don't need to change the offset. The color is still two floats from the beginning. And I'm just gonna add another attribute enable here. So that's gonna be attribute 2. Attribute 2. The size is gonna be 2. Let's just go through all of the arguments again. Index is gonna be 2. Size is still 2. Actually, I changed it to 2. It was 3 before, so it's gonna be 2 because it's U and V. So it's 2 float components. Still GL float. Still not normalized. So the stride is the new updated 7 stride. So that stays. That's the same for all of these. And then offset. Okay, so what's the offset gonna be? Please have a think and sort of recall what offset means when binding attributes. So recall what I was saying in that lecture. It's how many bytes, but since we're timesing it by size of float, we just need to worry about how many floats. How many floats in from the first, the first data of a vertex? How many floats inwards before we get to this attribute data? So the first data is the position here. There's offset 0 of every vertex. And then we gotta move in 1, 2, 3, 4, 5. So we gotta move in 5 floats to get to the UV data. So 2 plus 3. So I'm just gonna type 5. So that means the UV data is always 5 floats in at every vertex. That's the offset. Cool. So now we made our attribute. Alas, nothing has changed. And that's because we're not using the attribute. We're not using the attribute at all in our shader. So let's make that happen. So I'm gonna go into our vertex shader, and I'm gonna just plop in here the vec2 a text chord. I'm gonna call that a position, a color, a text chord. All right, so I've added the attribute here. It's a vec2. And I'm just going to pass it over to the fragment shader, just like we do with f colors. I'm just going to do, out vec2 f text chord. Because I just want to print it out, just like, as much as print you can do in shaders. I just want to output what the texture coordinate is just to see what it looks like. So I'll just comment this out for now, and then I'll do f text chord, a text chord. Like so. So I'm setting the out parameter of the vertex shader. So that's going to get passed to the pixel shader. Or fragment shader, I should say. That gets passed to the fragment shader. So I'm setting the output to be just whatever the attribute is. And again, that's going to be interpolated between the vertices for each pixel. So here, instead of in f color, I'm also going to have in vec2 f text chord. Like so. So that's going to be the input from the vertex shader. And I'm just going to set the color to be that. So I'll just do color is equal to vec4 f text chord. And that's a vec2. So that's going to set the x and y component. And then I'll set the z component to be 0. And then the alpha to 1. There we go, and I'll comment this out for now. So let's see what happens. Okay. So that doesn't look right. I didn't expect there to be like this dash in the middle and this red here and green there. It should be the other way around. This should be green. This should be yellow. Okay, so what's going on here? Well, I sort of did this intentionally, actually. You saw me commenting out stuff that I didn't actually have to comment out. The problem is, if you remember, like way back, just cast your minds back to like last video where I was talking about how are these input parameters here mapped to indices of attributes. And I was saying, the first input gets mapped to attribute 0, and then the second one gets mapped to attribute 1, and this one gets mapped to attribute 2, and so on. And here's where the GLSL compiler sort of can trick you a little bit, because the GLSL compiler is very greedy when it comes to performance. It wants to maximize performance at any cost. And what it does is that it sees we're not using this A color here. So see, I commented out this line. That actually was done on accident. This highlights that the GLSL compiler saw we are not using that A color. So I'm just going to remove it. So this actually gets removed. All right. And then what happens is the text coordinate is suddenly the second attribute. So it gets mapped to attribute 1. All right. And we told it attribute 1 should be color. So all of a sudden we're feeding color data into our texture coordinate, and we're getting these weird results because we're reading just the first two values of it. And we can actually double check this if we look at the values. I mean, if we cast our mind back to which colors did we actually give each vertex, we gave this vertex rather red, this one green, this one blue, and this one white. And if we just lop out the blue component, so if we just ignore the blue component, this is exactly what we expect. We expect red and green to be unchanged because that doesn't even have a blue component. The top right corner was supposed to be blue, but since we're ignoring the blue component, we're lopping it off as a vec2 instead of vec3. That just becomes black. And this one was supposed to be white, but again, since we're lopping off the blue one, it just becomes, red and green, which is yellow. So that's why this corner is yellow. This is just the color data without the third component, without the blue. Okay, so how do we fix that? I mean, we could just map this to attribute 1, but it becomes kind of annoying to have to keep track of which attributes is the shader ignoring and compiling out, and that can be kind of uncertain about how does that work. Well, there's a tool for this to actually manually say in the shader which attribute do I want this input parameter to be mapped to. And you do it like this. You do layouts, and then in parameters, location is equals to 0. So this will say this input parameter, this input attribute, map that to attribute index 0. All right. And then for our texture coordinate, I'm going to back out a little bit to get back the color. Layouts, location is equal to 0. And our color, we want to map that to location 1. And then text coordinates, we want to map to location 2. Like so. So now it doesn't matter if color gets optimized out, because, even though this doesn't exist anymore, in the shader, this will stay. It will keep we've specified this gets mapped to attribute 2, so the result will be that there just isn't any attribute 1 in the shader. Nothing is bound to attribute 1, which is fine. It just skips that one. All right, so I'm just gonna add these layout locations, and there we go. Now we have something that we actually expect. We're expecting the top left corner to be black, this one to be green, because 1 in V is 1 in Y, which means green. This one is red, and then this one is yellow, which is red and green combined. So there's our nice UV square. Fantastic, looks pretty good, I would say. So now we want to sample a texture. And that's actually pretty easy. We actually don't need to do anything. We just go into the fragment shader. Or we need to do something, but we don't need to do anything in code. We just have to modify our shader. We're going to make a uniform, okay? So we're going to make a uniform sampler 2D, which is a special type of object that provides sampling of a 2D texture. Remember we did the GL texture 2D? This sampler is for that type of texture. It's also a sampler cube, and so on. So we'll do U sampler, I'll just call it that. Great, and then instead of just setting the color to be the text chord, I'm just gonna do O color is equal to texture. All right, texture is a special function, and let's actually look it up. GLSL texture. That's hopefully that gives me the right thing. Yes, here we go. Okay, cool. So texture takes a sampler. It takes a sampler for the first argument, and then on the second argument it takes the position, or the UV. But it's UV is only for 2D textures, so when I say position, I mean whatever position for that type of sampler. So here we can see G sampler 2D, and then it takes a vec2 for its position. And here's sampler 3D and a sampler cube, and we have arrays and cube arrays, and there's all types of different samplers for different purposes. But we care about this one, this sampler 2D. So we're gonna pass in a sampler 2D, and we're gonna send in a vector 2 to be the position, and that's gonna be, you know, where on the sampler square do we want to get the pixel. So we are gonna send in the U sampler, and then we're gonna send in our F text chord. Whoops. And let's see what happens. So I'm just gonna run. Da 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 da. By golly, it's our texture. Look at that. And there it is. It looks so good. So that's textures. Yeah, I think I end the video there. We're gonna play more with textures later, but you know, stay tuned.